I'd like to welcome everybody today to our From Research to Implementation webinar. This is a series. We're getting close to 3 years. It's pretty exciting to me. My name is Travis Walbeck, and I am the Training and Outreach Manager here at NCAT. Our topic today is ignition furnace correction factors and temperature recommendations. There's a lot of work that's been done since the inception of NCAT, really, with the ignition furnace, and it's still ongoing. So this is some things that we want to share. A couple housekeeping things for you. Remember, we're on here every third Thursday at 10 a.m. Central is our time frame. Please keep yourself muted during the discussion. We're going to change things up just a little bit and do questions early for Dr. Redesno because she needs to be teaching class at 11 a.m. So if you've got questions, please put them in the chat box and I'll get those shuffled to her as is appropriate. If you have additional questions after that, then please put them in the chat box as well, and we'll kind of gather things from there. So given that, I want to introduce our presenters today. So Dr. Carolina Redesno is an associate research professor here at NCAT. She joined NCAT in 2011. She's got more than 18 years of experience in asphalt technology. Her research expertise includes sustainable pavement materials, performance-based asphalt mix design, field performance evaluations of pavements, and asphalt material testing procedures. She's been involved with and written reports for many different organizations, including NCHRP, FHWA, NAPA, and State DOT. She's done plenty of research with them as well. She teaches at Auburn University and assists NCAT in instructing our courses that we do here related to asphalt technology as well. Our guest today is a good buddy of mine named Casey Nash from the Maine DOT. He's a professional engineer there in Maine. He specializes in asphalt pavements and its constituent materials. Casey's a member of the AASHTO organization, which is the Committee on Materials and Pavements. He's also part of FHWA's Asphalt Pavement Materials Task Force Group. He's a part of AAPT, the Association of Asphalt Pavement Technologists. He's on the standing committee at TRB AKM 20, which means nothing to me. I'll have him tell us what that is later. I love that we put the actual names in TRB stuff instead of just the abbreviations. But he's also the vice chair at Comp on technical section 2D, which is a proportioning of asphalt aggregate mixtures. He's got almost 20 years experience with the last decade of this being really focused on asphalt pavement materials. So given that, we'll kind of get started with things. As we kind of outline the way that we're going to work through things today, we're going to have an introduction. I'll give a little bit of that. We'll talk about the NCAT research with Dr. Redesno. Do a few questions with her. We'll talk agency perspective with Casey Nash, and we'll do some questions there. I'm going to give you guys a few resources, and we'll close out. So, given that, a little bit about the history of the ignition furnace that was developed here in the early 1990s at NCAT, and not on our current facility. This work was being done on campus when NCAT was in its infancy. It's really fun if you ever get the opportunity to talk to Ray Brown and hear about how this came together. He had a graduate student that needed research to work on. They didn't quite know what to do, so he kind of put together this idea. Maybe we can burn off the asphalt and look at what we have going on from there. He's got some great stories to tell about how that worked and how that went through. But one of the great things that happened through this is the reduction of the need to use solvents to do extractions. There are still plenty of agencies that use solvents to do extractions, and there's some wonderful new technology out there that still uses solvents. But just like today, when we have this threat of some of our solvents being made illegal by the federal government, some of this stuff was happening back in the 1990s as well. So this dramatically reduced that need for the solvents, for disposing of that waste material, for those fumes to be around in our laboratories and so forth. Plus, it left us a recovered aggregate, which was really suitable for sieve analysis, so we can make sure and check. We can pull quality assurance samples from production, do the ignition burn off, find out exactly what our asphalt content was, and then we can grade it to make sure we met our gradations as well. So there are a lot of great benefits to that. We kind of look at the timeline of how this all went together. You know, it was about 1993 or so when the experiments with various furnaces, they were using some muffled furnaces, which burn really hot, but aren't necessarily vented. And they worked on different ways to use those, worked on different temperatures. What was the appropriate temperature to be using to burn the petroleum-based asphalt binder off of the aggregate, but not damage the aggregate. And they messed with the sample size. The initial muffled furnaces that they were using were really small, and they weren't really getting very good size sample to burn. In 1994, the reduction in test times was introduced there with this continued work. They started looking at forced draft furnaces, which helped get the material or the burnt off soot and whatnot out of the furnace. They looked at stainless steel pans as a vessel for the material to be in while it was doing this burn off, and they started using bigger furnaces, which has allowed them to use a larger sample sizes. In 1995, there was a report published by NCAT. That's report 95-02. Dr. Ray Brown is the primary author on that, and it documented the development, but it also talked about the precision and environmental benefits of using the ignition furnace. Something else that was done in 95 as part of this was some round robin work, because there were different agencies and contractors to which were trying to use these furnaces, and we wanted to make sure where we were lining up with those different things. So we really started seeing in the mid 90s that industry and DOTs started adopting this technology, and adopting it enough that there were AASHTO and ASTM standards that were developed and published to standardize the use of the ignition furnace. So in the late 90s, there was additional improvements in there, the addition of internal scales, so that we could watch and see when that mass change stopped and reduce that burn time. There was also some refinement of the accuracy and the efficiency of how the ignition furnaces worked. In the early 2000s, there was the introduction of infrared technology. Troxler led the way with that. They were the ones that were really pushing for that. And in 2002, NCAT released a report on using the infrared versions of the ignition furnaces. And then really up to the present, there's been ongoing refinements and calibration correction factors, all sorts of work that's been done there, which really leads me to turning the time over to Dr. Redesno so she can tell us about the work that she has done recently.
Thank you for the introduction, Travis. The information that I'm going to be presenting to you today is data that came out of 2 NCHRP projects that we completed. Project NCHRP 956 was completed in 2017, and then a follow-up project continue on Ignition, and this is project 956-8. So those 2 projects were sponsored by NCHRP. A little bit about the test procedure. We know that the accurate determination of asphalt content and to know the aggregate gradation is very critical when we are trying to deal with quality control of asphalt mixtures during production. Even nowadays that we are dealing or trying to transition to a new way to design asphalt mixes with balanced mixes, and we still need to know what the asphalt content of a mix is going to be. So it's still a very important topic to discuss. We know that the ignition method using AASHTO T308 is widely used, one of 2 methods most used by agencies. The procedure is very basic. If you look at the procedure, you have an oven that is used to burn the asphalt that is in the aggregate. And the procedure terminates when all the asphalt is burned. And this is indicated by there is no more change in weight of the sample. No, there is no more binder to burn. What is important to understand with the ignition oven test is that correction factors are needed to account for differences that you're going to find between the actual binder content and the results that you get from the ignition because of aggregate breakdown. You have to understand that that aggregate breakdown is going to be dependent on the type of aggregate that you have, that you are using in your mix. So if you look at the primary purpose, let me see, I'm getting rid of something here. The primary purpose of the correction factor is going to be to determine the need adjustment that you have to be able to convert the measured asphalt content to the actual asphalt content of the mix. You also have to realize, let me move to the next. Let's try, okay. You have to realize that there are two common procedures, as I mentioned previously, to determine asphalt content. You have the ignition and you have solvent extraction, as Travis mentioned previously, according to AASHTO T164. What I'm presenting you here to have an idea of how the precision of the two procedures look like, you have the results of the precision statement of AASHTO T308. I'm gonna see if I can use my pointer here. Right here, the first column, and then you also have the precision of the solvent extraction. And as you can see from these results, the precision of the AASHTO T308 is better than the AASHTO T164, even if you look at the acceptable range of two test results. For single operator, for example, for the ignition is half or less than half what you will have for the solvent extraction test. What we have to realize that even though the ignition method is very straightforward and more precise than solvent extraction, there are still issues that can be improved. One of them, as we mentioned previously, is the need of correction factors. In some instances, we also have cases where agencies and contractors share correction factors between ignition, which is something that in reality should not be done. We also have regions of the country that use aggregates that have a relatively high correction factor, and that's a result of the type of aggregate. As I mentioned, dolomites are going to be some of those aggregates that are going to have a lot of breakdown during ignition. On top of that, now we are dealing and trying to go up with the amount of recycled materials that we are using in our mixes. And as you are aware of how the procedure is conducted, the correction factor of those recycled materials is unknown because there is no way to track back what the raw materials were to be able to establish that correction factor. So there are some issues that can be improved. As I mentioned previously, many aggregates are going to have different mass laws. Some aggregates have low mass laws, and in those cases, probably not having a very accurate correction factor is not as critical. But then when you are dealing with these type of dolomite materials that have a high mass loss, we are dealing into a bigger problem here because you may have loss of up to 2%. If you look at the AASHTO procedure currently, they allow you to reduce the temperature to 900 degrees to be able to account for the breakdown that happens in ignition. But even at 900 degrees, when you run the test at 900 degrees, correction factors for some aggregates remain very high. As I mentioned previously as well, correction factors should be developed when you are using individual pieces of equipment. Even if you are using the same brand of equipment, you have to establish correction factors for that piece of equipment. And that's something I'm going to show you that we ran some round robin studies and we saw very big differences when equipment of the same unit was used for the same mix. This highlights the need of developing correction factors for each piece of equipment. Once again, sharing correction factor is not good, but it's very often done by the agency. And in general, as I mentioned previously, sharing correction factors when these numbers are small may not generally be as critical as when you are doing that for aggregates that lost a lot of mass during ignition. So going back to the study that we did as part of NCHRP 956, and I'm going to try to go over some of the key findings. We did a sensitivity study where we look at different variables to identify what variables were actually affecting and causing this variability in ignition correction factors. And what we found is that by looking at different variables such as mass of the sample that you are burning, the asphalt content of the mix, the temperature, the airflow that you have coming into the unit, we found that by far the factor that affects the correction factor the most is the temperature. And here it's just a quick plot that shows the correction factors what we found when we were testing mixes at 800 degrees compared with 1000 degrees Fahrenheit. We included 4 mixes in that evaluation, and as you can see, For mixes that have a low correction factor, like mix 1 and mix 2, that difference is not as critical. If you look at mix 2 with negative correction factor, it's because that particular mix used lime, and we know that lime will cause this effect in the correction factors, and it's something that we also have to be aware of. But if you look at other mixes that use like dolomites, you see how that difference in the correction factors when you are changing the temperature increases significantly, and this is where we really have room for improvement. As part of that phase 1 of NCHRP 956, we conducted an interlab study, and the purpose of this interlab study was not exactly to develop a precision statement, but to look at what factors were affecting the results that you were getting from ignition. And here what I'm trying to illustrate is those numbers that I show you when, even though you were using the same type of brand, the correction factors had big differences. Same mix that we were using, in this case, mix 3 from that phase. Just to illustrate this case, you have the asphalt correction factors for the different labs that run the tests. First, you have Thermoline. All these units were Thermoline units. Gilson was another brand that was evaluated, and then Troxler units. As you can see, like I mentioned, you have an average correction factor of 0.92 with a minimum of 0.55 and a maximum of 1.51. So once again, even though you see lab 4 has a very low correction factors in the range of, lower correction factor 0.6, and then on the other hand, you have lab 17 with a 1.4 correction factor. So once again, when you are trying to share correction factors, is when you can be really messing things around when you are trying to determine asphalt content. So as I mentioned, the objective of this interlab study was not to develop a precision statement, but we had all the data. So we gathered this data together to look at what numbers we were getting, and I'm trying to summarize the results in this table for the 4 mixes. You have the average correction factors that we go from all labs, and then you have the standard deviation within lab and between lab. And as you can see, as the correction factor of the mixes increases, you can see a big change in the standard deviation within lab and between lab. And at the bottom, I'm just presenting you what are currently the limits that you have in the AASHTO T308 procedure compared with the numbers we got by mix type. So the key findings from project 956, and keep in mind that we did many other things, but I'm trying to be brief here, is that the results suggested that the precision statement in the AASHTO procedure probably was developed using aggregates that had low mass loss. And this precision statement that was developed for these aggregates may not apply to aggregates that have a higher mass loss. We also concluded that tests conducted at a reduced temperature of 800 degrees Fahrenheit significantly reduced the asphalt correction factor, particularly for these troublesome aggregates that we've been discussing so far. So based on these recommendations, we suggested that reducing the test temperature from 1000 degrees to 800 degrees could translate into lower correction factors and potentially reduction in the within lab and between lab variability. So it was decided at that point to continue with a phase 2 in this study to look into developing a new precision statement. On top of that, we decided that it would be a good idea to incorporate mixes with recycled materials, because once again, by reducing the temperature to 800 degrees Fahrenheit, when you are using these recycled materials, you are also reducing the correction factors that is going to be unknown, and then the effect that you're going to have in the determination of asphalt content is not going to be, or the difference that you have between the actual and what you are getting is not going to be as significant when you are reducing the temperature. So once again, the objective of the phase 2 was to evaluate the effect of reducing the test procedure temperature and to conduct an interlab study, but in this case, the interlab study was meant to develop a new precision statement for the AASHTO T308 procedure, incorporating virgin mixes, but also mixes with high RAP content. Once again, a little bit of information about the interlab study that we conducted. We have 10 labs that participated. We use 8 mixes, 4 virgin mixes, and 4 mixes with high RAP, recycled asphalt material content that included shingles and RAP material. We send a bunch of samples to each of the labs for them to conduct the test, and we provided instructions to the different labs on how they will gather the information for us to develop the precision statement. Once again, I'm not going to get into a lot of details about the mixes that we included, but just to give you an idea, we provided a big range in terms of nominal maximum aggregate size, asphalt content. The 4 mixes that I'm showing you here are just the one that had RAP or recycled materials, just to highlight that in the study, we were using higher, what is considered high RAP content or recycled material content in the range of recycled binder ratio was in the range of 0.31 to 0.36 in the evaluation. So once again, a little bit of information, 8 mixes were included. Mixes with high recycled material content, 10 labs, and detailed instructions that were sent to the labs to run the test. So after we gather the information, we follow ASTM recommendations to develop the precision statement. And this is the data that we came up with for the 8 mixes, including the 8 mixes. So as you can see, what I'm trying to point out here quickly is what we got in terms of the pool estimates of the standard deviation. As you see at the bottom, you have, for comparison purposes, the results that we got compared with the AASHTO T308. 0.073 is the number that we got from our study compared with AASHTO T308. And then if you look at the between lab, you go from 0.117 that you have currently in the AASHTO procedure to 0.146. So that was the outcome of the phase 2, where we developed this new precision statement, keeping in mind that the instructions including tests to be conducted at 800 degrees for all the mixes. So from the second phase, a revised precision statement was developed with the inclusion of virgin and recycled materials. I already talked about the precision values for the repeatability and reproducibility standard deviation. We also found that the results suggested that the virgin and recycled mixes do not require different precision statements. They were, we assessed the results and they look to be in the same range. So we grouped them all together. I didn't present information about gradation analysis, but we found that the current AASHTO limits that you have in the procedure don't have to be changed, even with the inclusion of recycled mixes. Once again, the outcome of the project was to make recommendations to the AASHTO T308 that included change in the test temperature and a revised precision statement for asphalt content determination. We also recommended that in the future, additional mixtures or mixes with other recycled materials are going to be incorporated. This is something that the precision statement can always be refined as we continue incorporating new materials into our mixes. Finally, just as I told you, this is a very brief condensed version of all the work that we did as part of these 2 projects. But if you want additional information, there are 2 reports, as I mentioned previously. NCHRP report A47 was the phase 1 published in 2017. And then you have project or phase 2. This is NCHRP report 1060 that was published last year. That's all I have, Travis. I'm going to stay here in case somebody have questions about this.
Well, good morning, everyone, and thank you to NCAT for offering up the opportunity here to be able to share just some of the our initial brief findings and our well, I guess I'll say main DOT, but more or less my thoughts on the topic of ignition sparks correction factor and temperature recommendations. Just some brief talk points here, just to give you the overall motivation and the initial results that we have found. We just did some preliminary investigation. We have more in-depth investigation planned for this winter. Kind of a brief overview of motivation and some of our results from the 800 to 1000 degree Fahrenheit temperature difference. Then I also want to briefly touch upon some of the differences between the ignition versus extraction. As Travis mentioned early on, some states, Maine DOT being one of them, still run extraction. We do it just on the wrap, not for asphalt mixture content determination, but we see there's value in potentially moving from asphalt content determination via extraction of the wrap and moving over to AASHTO T308 ignition, and then just the overall conclusion. So our overall motivation is, as Carolina mentioned there, the AASHTO 956 alpha, it indicates that 800 degrees provides more consistent correction factors for both virgin and recycled mixtures. It's important to us to be able to increase our accuracy, precision, and consistency as much as possible in our testing, especially as an agency when we have to, when pay is associated to these results with the acceptability of materials. And then from the recycled material side for us and also for some other states from a mixture standpoint, solvents used in extractions, they're becoming increasingly costly to purchase and dispose of. There's additional and increasing safety and ban concerns, as Travis mentioned early on. I'll just start right in with just some of the bare bones data that people generally would like to see. AASHTO T308 calls for 2 correction factors to be run, and then if it exceeds 0.15% between the two, then 0.15 between the two, then you throw out the high and the low after running 2 additional results. Maine DOT, we run 4. So the results that you see here are the average and standard deviation of 4 correction factor splits. Every single correction factor we run, we make 4 right up front. So there is no need to be able to throw out high and low. We consider all test results valid, but we average all 4. So each of these burns at 1,000 degrees and 800 degrees are the result of 4 separate splits, so 8 total for each of 3 different mixtures. You see in the mix design nomenclature there's the 95 FMTR, that's just a fine graded Microdevol approved thin lift mixture, and the R is the important piece there. There's recycled material, there's wrap included within that mixture. So you see the middle material there is just a 12F. So that's a virgin material. So when we lab batch those, we have very strong confidence in the overall asphalt content in that mixture because there is no recycled binder content added. So when you see there that the average correction factor at 1,000 degrees came out to almost 0.7, but at 800 degrees, it came out to 0.07. And so that's obviously a great deal of significance there because we have confidence in the asphalt content value. So the fact that it borderline, the average came out close to 0, as would be expected with the if there was full combustion of the asphalt content and the known contribution included. And the overall standard deviation of that virgin material was relatively comparable. It was, a slight increase with the 800 degrees, but it's not. It's within the standard variability of that test. So that's deemed not significant. You'll see on the 2 recycled materials, there was also a significant decrease in the average correction factor from around 0.5 down to close to 0.1, 0.2 range. But more significantly, it was the standard deviation was reduced by a factor of 2, pretty much. So that, so our initial findings are showing that just like NCAT's work showed that there was a significant reduction in the average correction factor. And for the recycled materials, there was a significant reduction in overall standard deviation of the results, being this work being the result of 4 individual test results. See here. I want to touch briefly though, because a lot of this discussion about the correction factor and the consistency of results is more specific to the precision. And I know many people have seen a very similar image to this. This one I just pulled off of sciennotes.org. Ideally, what we want to try to get is the top left portion of this image to be able to achieve high accuracy and high precision. What we're talking about here is that basically with increased precision, we're moving to the left side of this image, but it doesn't necessarily move into the top left. There's also concern that we may be moving to the bottom left, that we may be increasing the precision by decreasing the asphalt temperature or the ignition furnace temperature. We don't have necessarily full confidence that the results therefore are accurate. Some previous work had been done showing that extraction provided a more accurate result. So although the results were more variable, some of the work was basically showing that they were more variable, but the overall average was more accurate to the true. So basically, what we're talking about is kind of more of the top right image there, where it's accurate but not precise. So when you have more results, so for our extractions, we run 6 on a recycled material on RAP, but the average is closer to the true. Some of the work through NCAT's work there, and some recent studies have increased the accuracy, I would say, of the ignition furnace determination. Some of our initial work there, so that middle material there, that virgin 12F, it doesn't have recycled material. After the burns, there were 4 individual burns, they all had repeatable results as far as the resultant material coming out of the ignition furnace had the quote unquote black rock remaining in the ignition basket. And so this raises a big concern of us, and some other states, and including Canada, actually had similar results, showing that the concerns that, well, if the asphalt isn't fully combusting, then we're not necessarily getting an accurate result. And that's where that lower left-hand corner there, though the results are consistent and precise, they may not necessarily be accurate. But again, you go back to that the fact that the correction factor, what did reduce down to 0.07 with a known asphalt content contribution, which would lead you to believe it's accurate from the decreased correction factor standpoint. But when you see remaining black material, which was assumed asphalt in the ignition basket, there's concern that it may not truly be an accurate determination of the asphalt content. This is very preliminary findings and an individual result, may I add, but it is of concern. Our lab personnel said that basically they were confident it was asphalt that remained on some of the rock. So as far, for moving forward, we plan on having some further investigation. Recently at the Committee on Materials and Payments, AASHTO and 2C, we did discuss the modifications to T308 recommended by NCAT and NCHRP 956 and 956 alpha. But some of the concerns previously mentioned from some states, including Maine DOT, we would like to have some further validation of the results with more widespread assessment of the materials and different variables of materials that are used within the mixtures. So we actually intend on utilizing the remainder of our correction factor. So at Maine DOT, what we do is every mix design, we lab batch the correction factor. So we actually create 8 separate splits of that material. 4 go to the primary lab, and 4 go to our secondary lab if dispute is required. If the contractor has disputable results for one of the asphalt contents. Several of those disputes that are always batched are not needed, are not used. So what we intend on doing is using all those additional 4 boxes of each mix design that are already fabricated, returning them back to the original lab to be burned in the exact same oven, to be able to have that, to look and further investigate that comparison of the 800 to 1000 degrees. We intend on sharing these results as we have previous results with AASHTO for further discussion with the T308 recommendations. With that being said, Maine DOT is actually interested in trying to reach out to additional states because we'd like for other agencies to join us in the individual evaluations, so that there is no, so it's a more widespread analysis and assessment of all the materials across the state. And when you spread out some of the testing and laboratory work amongst multiple labs, multiple states, then it will allow AASHTO to be able to make sure they move forward in the correct direction, making sure that all the recommendations from 956 alpha have been validated and verified prior to incorporation into a standard. I mentioned I wanted to briefly touch upon the extraction versus ignition work. As mentioned early on in Carolina's presentation, she said that that there is increased consistency and precision with ignition. This year, this is on RAP material, but you could have a similar comparison with asphalt mixtures. And you see that it is true that there you see the error bars there overall are significantly decreased. And there's far more consistency with the results through the ignition furnace. These results are at 1000 degrees Fahrenheit for the ignition furnace. But as previously mentioned, there was some that there was concern about the overall average with the extraction being closer to the actual asphalt binder content. And then there's also the piece and aspect of when you talk about the material gravities, the stone gravities, there is belief that when you do a solvent extraction, the gravities of the resultant material is more accurate and consistent than via ignition. But we do have a desire, because a lot of our industry partners actually measure their RAP asphalt content via ignition. So it being more consistent, as long as we could develop a RAP offset or correction factor itself. Some states have 0.3, 0.4% RAP correction factor. That's something we're investigating and considering ourselves by doing extraction and ignition comparison, and then having a correction factor offset. But if as further investigation leads us towards ignition being more precise, if we can increase the confidence and the accuracy of the asphalt content, then we could wholeheartedly we can move to mixture and RAP assessment via ignition, as well as in considering the increase or the decreased temperature in the ignition furnace. One other piece that we had considered here, where with the increased asphalt content through the ignition, we had wondered if maybe there was additional superfines lost through the exhaust. So we also had looked at, we did a gradation of all of these materials, and you see that there's actually an increase in the percent passed in the number 200 as well. These are the exact same, all seven of the same materials. And you see that overall on the right-hand side, there was a slight increase in the overall average of the percent passed in number 200. So if you saw, if it was a result of superfines or anything lost to the exhaust, and you were seeing that as a measurement of asphalt content, you would expect to see a reduction in the number 200 going through, when you go and actually sieve the post-ignited material. And that wasn't the case. We actually saw a slight increase in the percent passed in number 200 as well. So this is kind of the impetus of our work at this point. We're continuing to investigate the percent passed in the number 200 to see if there is a relation in the increase or decrease asphalt content through ignition. And we are going to further investigate the ignition furnace temperature at 800 to make sure that it wasn't just a one-off result of incomplete combustion, and that we are going to make sure that all the asphalt content is burned off. So in conclusion, Maine DOT, some of our initial findings do agree with NCHRP 956. All the work that we have completed at this point does show that there is increased precision as you go through the reduced temperature. But as you can see in some of those images there, there is concern for incomplete combustion. It wasn't just a single basket either. So we don't know if there was in fact incomplete combustion. One of our discussions after the fact is we wish we had reburned that basket out at that 1000 to see if there was a further reduction in mass. But that's why we're going to go look further into it this winter. Again, the additional validation this winter, we're going to be continuing to assess 4 different replicates that have already been burned at 1000 degrees, and then we're going to be Fahrenheit. And then we're going to also be burning them again at 800 degrees Fahrenheit. We would really appreciate, and we'd like if multiple other agencies across the nation would also help and assist with validating some of this 956 alpha recommendations, so that we have unbiased weighted discussions with the SOT 308 recommendation changes. And then SOT 308 is a more consistent measure of asphalt and RAP than T164. It is more precise, but again, we need to make sure that it's more accurate. So while we increase the precision, that's where that correction factor offset comes into play, but you don't know what your asphalt content is in your RAP. And so that's where we still need to consider if there is a need to continue to run extractions on recycled material, millings, or from a roadway, when there's an exact known what the asphalt content is in that mixture. So I know I went over that kind of quickly. I didn't want to waste a great deal of time because there may be some questions associated with some of this material. Any of the results from the asphalt content ignition and extraction of the RAP, I just shared some of the graphs on that just because there's a lot of data to try to share in a table. If anybody would like to see the exact numbers, with any of this material, feel free to reach out, and I can share that information with you.
Hey, Casey.
Yes, Carolina.
Hey, a couple of questions for you. You know, we did the interlab study where actually different labs were running, and as we reported, when we were using Troxler unit, you were not using Troxler unit because there is no reference to that. We did see that, and we adjusted the burning profile to account for that. We adjusted burning profile, but none of the labs really reported that, what you found, which is kind of puzzling. What we do recall is that when you have the leftover aggregate, you know, typically you see this white ash that is left. In some cases, you will see that ash being a little bit darker than the white ash, but not really leftover asphalt, you know. It would be interesting, and we will love, you know, to kind of follow up with you on that if you're going to continue doing evaluations, since we did this multiple times. We didn't get really come and say, you know what, we have all this asphalt left. We did have that for the thermal for the Troxler unit. Once again, that we thought that we fixed that issue with the burning profile, but again, I think it's something that we would like to help you any way we can. I don't know if it's the source of aggregate that you are using something, but we would love to follow up with you on that.
Yeah, no, I appreciate those comments, Carolina, as
Yeah.
well. I'll admit I did not get to see and visually inspect the material myself. So you know, the information I'm sharing here is you know, secondhand from our laboratory staff, but they voiced significant concerns. And so I obviously take all consideration, you know, deep consideration into all of our laboratory technician concerns that they voice. I can't tell from the images if it is in fact asphalt that remained on the aggregate. And that's something that I had mentioned as well, is that sometimes, you know, like you go outside and you have your bonfire and your good old fall time bonfire. And after some of it, you have some of those white gray ashes, but then you also sometimes will just have some black ash, and you touch it and it's black on your fingers, but it doesn't necessarily mean that there's organic material or wood particles or whatever it is you're burning that is actually left. So I agree with you wholeheartedly. It's just there with that increased concern, and like I said, there were two other specific entities during the Committee on Materials Payments meeting that had voiced that had stated that they had seen similar impacts and similar effects. Again, I can't truly quantify it as being asphalt remaining on the aggregate. That's why it's called, you know, quote unquote black rock. It's just like, well, I said there was still black rock, and as you can see from that image, I'll just snap back real quick. You can see to that image that, you know, that it to me, it does appear, if you look down like in the you know, I'll switch over to my pointer as well. You know, it looks like to me you can see some of it flaking off, right? And if it was asphalt content, you wouldn't see flaking falling down into the pan, because there would still it would still have that cohesive aspect and everything and that adherence. So but then again, you see some other ones that it does look like it is fully adhered to the stone. So without being able to see it more intricately and, you know, and actually investigate thoroughly myself, I am kind of limited to the third party. But then you see, like over in this pan, there's a significant amount of black.
Yeah.
And so it was very concerning to our staff.
Yeah, like I say, we would love to follow up on that, because you know, you were using thermoline units, right? These are thermoline convection units, right?
I'm sorry, Caroline. I would have to go down. We have a couple different options, but primarily, yes, I believe they are all thermoline.
Yeah. Thank you, Casey.
Yes.
Just shoot me an email when you're continue doing this work.
Yeah, we plan on doing a little bit more of this. We also have some questions about, you know, the fact the initial runs of those 1,000 degree Fahrenheit correction factors were run when they were initially batched, and then the remainders were boxed up and shipped down to our secondary lab. And we want to make sure that there isn't an effect of overall, you know, just absorption of the material over time and going through the reheating to be able to split out, or you know, any of that time component, because there are some of those have months and sometimes a year difference between when the initial 1,000 degree and 800 degrees were run. So we want to do them back to back, just to make sure that we remove and limit the variables that could be confounding our results.
That makes sense.
Cool. A couple of questions that have come in. One of those questions in here is the results of the higher than usual correction factors using the high wrap. Is there a consideration that there may be moisture in the wrap, and that's part of where that comes from? And I know I've had some of these discussions as well about, are we burning off some water that's in that wrap? I'm hoping most folks are completely drying that wrap and spending a lot of time in a low temperature oven to get that dried off and work with that. But I think the flip side and the problem to that is are we getting it dry enough when we actually move into production? So certainly we're talking about looking at it at the lab side here, but I want to move that into that next phase too, and to make sure folks are thinking of that way. But Carolina, have you found any issues with the additional drying of the wrap there, confounding results?
I mean, when we did this in our lab and when we sent our samples, I don't think absorption wasn't, moisture was an issue there. So
Okay.
And if he's referring to the results that we show, some of these mixes were from known sources of high loss materials, that's why you also see kind of higher correction factors there. Yeah.
Sure. Casey, did you guys think you guys saw a difference there?
Yeah, so we actually offer, we have two different options in our lab where we can we'll follow the mass determination when it stabilizes to be able to guarantee that the actual moisture has been fully evaporated out of the recycled material prior to the extraction process. Or we actually also have the process where they can put it in a low temperature oven for a minimum of 24 hours because we've done a significant amount of work to show that we never had any massive reduction after 10 to 12 hours. So 24 hours was guaranteeing that the material was dry without actually burning off any a material that may be impacting the results. So I'd say I'm confident that we haven't seen a moisture confounding aspect to those measured values. But you never know for sure. But I would say I'm confident in our procedure that it is as accurate as we can to ensure that all the moisture, all the liquid has been evaporated.
Well, and to me, part of that comes down to just making sure that we've got sound research principles underneath what we're doing here. So, and I'm confident with both of the labs here. So another question that's come in here: will there be any look at comparing the precision in the AASHTO T308, compare that to the ASTM D 8159, not just looking at extraction versus ignition? So Carolina, have you looked at any of that difference between the two standards?
Is this the automatic extractor, the new equipment?
The 8159, I'm not positive.
If that's what they meant,
I'll Google it real quick.
There's standard test method for automated. There is no follow-up on this study, but we actually did a study a few years ago, probably 2018 or 16, for Wisconsin DOT when they were first looking into it, into the automated extraction method. It was limited, but we came out with some precision statements for their mixes. So like I said, there is no follow-up as part of NCHRP or anything that we are doing currently, but there was already some interest on that.
Sure. And we just had ours delivered, a month ago?
Yes.
Right. So we're just barely getting that equipment. Casey, have you guys done any work with auto extraction yet?
So we haven't worked with the auto extractor ourselves directly. We've had a great deal of discussions with other agencies and entities as well as equipment providers that have they've all across the board said that the auto extractor does produce more consistent results. So where I was showing some of those extraction results through the through a rotary type extraction equipment, that increased variability, it did show that there was a reduction across the board. Everyone's reported the same findings, that there is a reduction through the auto extraction process because you're limiting some of those user variables and other potential variables. From what I've seen from a data analysis standpoint, though, it is still not as significant of a reduction as in the precision and the variability as you see with the ignition furnace. Those results from everything that I've seen at this point are still more consistent from overall materials, recycled materials, than the auto extractor. So, and with that auto extractor aspect, so yes, to more specifically address the question there about will there be a comparative analysis between AASHTO T308 and ASTM D8159? The answer is yes. There's AASHTO and ASTM have a good partnership where they go and any time any of these test standards are evaluated and modified, they go and make sure that there is consistency amongst the changes. And sometimes there's an agreement between the two as far as what direction they will go in. So yes, there will be, if there are updates to the precision statements with the AASHTO T308, there will be a consideration for consistency comparison with ASTM, and then there will also be an inconsistency between T164 and ASTM D8159.
Okay, great.
Travis, something quick, because I think this is important. I didn't have time to cover this, but you also have to keep in mind, people always think, even though you have higher variability in the test itself for extraction, you also have to take into account that what we found from a couple of studies, at least, when you are dealing with these soft aggregates, extraction, sometimes you can find huge differences between the actual content, asphalt content, and the one you measure from extraction. When you have these softer aggregates with high absorption, we simulated some RAP in the lab, and we found differences that were as high as 0.35. So in many cases, you have to realize, don't think about the extraction as the bulletproof procedure that will give you that value that is closest to the actual AC content. And I think that was significant for us to see those big differences where you say, okay, extraction, you have a high variability, but also high numbers there. Big differences. So
yeah, I think that is important to know.
Yeah.
One more question that came in real quick, and then I'm going to get on to our kind of closeout here. But it looks like the tests were done on these medium nominal maximum aggregate size mixes, the 9.5 and the 12.5. Would you expect to see higher correction factors when you get into the 3/4, 1 inch? And they've got the 37.5 millimeter listed here, but I hate using that one because it's so prone to segregation.
We went as high as a 19. I think 19. I don't remember if it was 25, 19. I think it was the highest nominal maximum aggregate size that we use.
Yeah.
And I mean, in theory, you would think, the coarser the mix, the less asphalt you are putting in. I would say you shouldn't influence that.
Okay.
But like I say, 25, 37, we didn't go that high. The mass will have to be reduced according to the procedure. The mass that you put in the basket, it's a function of the nominal max. So, yep.
Yeah. Casey, you got thoughts on that one?
Yeah, I agree. Some of our investigation into it, the highest we also go is 19 millimeter. And there wasn't a significant increase in the correction factor as you increase nominal maximum aggregate size. And as Carolina alluded to, the asphalt content is higher with the finer or the smaller nominal max. So with that higher asphalt content, you commonly see more variability within those results instead of stability. I do not believe there would be a significant increase if you go to the 1925, 37.5 millimeter, though our investigations at this point have capped out at 19 millimeter.
Okay, that makes sense. That makes good sense to me. Ooh. I got stuff popping up here. Okay. Wanted to share a couple things with y'all that I kind of pulled away from here, as we look at this ignition furnace correction factor kind of recommendations and takeaway. Find a nice little typo there. I love it. The precision is tighter than what we see with solvent extraction. And I think we saw that with both the work that was done for the NCHRP and the work that was done with Maine DOT there. Those dolomite aggregates obviously have higher correction factors. That the round robin testing did establish and update those precision statements for the lower temperatures, and those recommendations have been offered into AASHTO to incorporate into T308. I do like Casey's discussion there that that you know, he mentioned during those comp meetings that several agencies are expressing concern about the full burn, and that they're still wanting to do a little bit further investigation. And I've got some ideas I want to talk to you about with that, Casey. I think we have some, you and I have access to some funding sources I think can help with that. Next was, you know, Maine was doing a bunch of comparisons with the 1,000 to 800, and they found correction factors did have that lower standard deviation. Looks like a lot of their findings that Maine was coming up with matched up with what they found in the NCHRP report. Certainly that full burn off is still a concern. So that's something coming up right at the last second. I was trying to take care of, but it didn't make it in here. I want to make sure we share emails. Carolina's email is that first email there. If you've got additional questions on the ignition furnace and the different things that were presented here today, feel free to reach out to any of the three of us. Casey, I'm selling your email address there on that web as well. But you know, these folks are the ones that have been doing that research, and I can get you in touch with the right folks pretty much at any point. But give that just another second in case anybody's trying to capture what those email addresses are. When it comes to us here at NCAT, you can find any of us by going to our website, ncat.us, and you'll be able to find every single one of us on there under the staff or the researchers. Next, I want to make sure we got those additional resources out there to you. You know, the NCHRP reports that Carolina talked about. There's the numbers. So the one was report number 847. The other was report number 1060. I was able to search and find those on the TRB website pretty quickly this morning. And so I would hope that if anybody has interest in seeing and digging deeper into this, that you could find them as quickly as well. Getting those searchable PDFs, I think, is really nice because you can dig in and find things closer. Certainly want to watch and see what the updates look like on the AASHTO T308. Looks to me like that was just republished this year, so this would have been findings that would have been discussed last year in the 2023 meetings. And Casey, where you are, I know you're very active, and even though you're not the vice chair of that particular subcommittee, but you're very active in those. So I appreciate your perspective on what was handled in those meetings. Other additional resources out there, you know, if you go to NCAT's website, ncat.us, you can click that little search button that's up there in the corner and search any topic that you want to, and it will show you any of the research that we have. So this is a quick search that I did this morning there, that just kind of showing, you know, all these different reports that you can find, and the, you know, the dates and so forth of when they were put out there. So the reports I mentioned earlier and some of the work that Carolina's mentioned can be found there on our NCAT website. And I want to plug Hey Napa. If you're not familiar with Hey Napa, please take a few minutes and look at it. Hey Napa is put out by the National Asphalt Paving Association. HeyNapa.com is the website there. This is a chatbot that's on the internet. It's built on the ChatGPT-4 framework. But the thing that I think is so critical and so important about this is it is only coming from vetted information that's either been published by NAPA, FHWA, or NCAT. And so these are peer-reviewed documents, and that's what it's pulling from. But it gives you a great look at things. The other thing that it does is it gives you full access to all of the resources. It tells you, it gives you citations of where it pulled the information, and gives you access to those PDFs online for free. So here you can see the other day I typed in and said, hey, give me a history of the asphalt ignition furnace. And I said, please, because at some point when these chatbots take over the world, I want them to know I was polite and nice, right? But it gives you some great information. So any questions that you may have about any asphalt topic, you can use Hey Napa as a resource there. I do want to invite anybody that wants to look at that NCAT research. Here's additional, just kind of the way that kind of looks out is you just dial in, if you don't just do a straight search, on the way that you can visit things in. Want to invite people to check out our YouTube channel, Training in Your Pocket. We don't have an ignition furnace one yet. I think that's one we need to do. I've got some equipment manufacturer partners that have been interested in helping us put one of those together. We just need to pull the trigger and get it done. But please, if you get an opportunity, check out Training in Your Pocket. There's lots of tests in there. There's equipment out on the road, especially folks that are wanting to are first getting into the asphalt industry, whether that's testing or paving. This is a great 3 to 5 minute videos that they can watch, and they're a little bit of humor built into them there, but it gives them that 30,000 foot view before they dive deeper into it, into standards and so forth. Please don't forget we have training courses offered all over. We do offer a lot here at NCAT, but we can take these on the road, travel, and do these wherever you may need them. Last thing I want to plug here real quick is our webinar for next month. Our webinar next month is going to be on November 21st. And that topic there we're going to have is the NCAT Test Track 9th Build Construction Lessons Learned. So we've got both Jason Nelson and Nathan Moore lined up with that. They're going to have some industry guests that helped with the equipment and the build that was done out there. I know they learned some really great things. And so that will be our next webinar that comes up. I have not switched the QR code over yet, but anytime you see this logo of our web series and that QR code, it's going to take you to the latest version registration there. So I'll get that switched over as soon as we sign off, and we'll go from there. Any last words, Casey?
I just want to thank you guys for having me. And by all means, if anybody has any further questions, please reach out.
Okay, thank you so much for joining us today. Thanks, Carolina, for your help with this as well. And we'll see you all next month. Thank you very much.